The next topic is types of formula for the basic operation count. Exact the formula in the basic operations are the example C of n equal to n into n minus 1 divided by 2. A formula indicating the order of growth with a specific multiplicative, the constant. The example of C into C of n equal to 0.5 into n square. A formula indicating the order of growth with the unknown multiplicative constant. The example of C of n equal to C n square. The order of growth, a most important order of growth within a constant, a multiple as n tends to infinity. For the example, how much faster will algorithm run on the computer? That is, they are twice as fast. How much longer does not take it to solve the problem of the double inputs? The values of some important functions as here n and log base 2 of n into n log base 2 n squared, n cube, 2 power n and n infinity. A geometric order of growth, a way of comparing the functions that ignores the constant factors uh, and small input of sizes. If O of g of n equal to class of the function, the f of n that grow no faster than g of n, and O of g of n equal to class of function f of n that grow at the same time, same rate as g of n, omega of g of n equal to a class function of f of n that grows the at least as the fast as g of n. It is in a graphical of the omega that it is does not matter O of g of n and t of n. It is a time value of big omega notation. T of n belongs to O of g of n. A big omega is uh, T of n belongs to omega of g of n. A big uh, a big notation of T of n belongs to theta of g of n. That means big theta. That means here g c1 tends g of n, t of n, theta 2 g of n. If the n notation of formula definition, a function t of n is said to be in f of the 0 of g of n denote the t of n and 0 of g of n. If t of n is bounded below by some constant of multiple of g of n, there are large n. Next, the omega of notation, a function of t of n said to be omega g of n denoted the t of n and the omega of g of n. If t of n bounded the both above the below by the positive constant of multiples of g of n for the large it n. The example if they are exist some positive constants of C of 1 and C of 2 and some non-negative integer of n of 0. If the circle of g of n that tends to theta of is a g of n is a greater than r, a theta of g of n is the function of grow at least the fast data of fastest g of n, then the omega of g of n is equal to a function that grow the same rate as the g of n. The next g of is an o of g of n is less than or function the growth no faster than the g of n. The establishing the order of growth using the limits. The limit tends to infinity. T of n divided by g of n. If 0 order of growth of T of n greater than order of growth of g of n. Next, C tends to 0, a order of growth of T of n is equal to order a growth of g of n. A infinitive order of growth of T of n is a greater than order of growth of g of n. For the example, 10 into n versus n squared. N into n plus 1 divided by 2 is an n squared. L'Hopital's rules of stringing as formula. It's the rule of if limited n f of n is equal to limited n g of n equal to infinity and the diverse derivatives of f and f dash and g dash exist, then a limit n infinity into f of n divided by g of n equal to limited n infinity f dash of n divided by g dash of n. For the example, log n versus dot n, strigling the formula uh, n infinity into 2 infinity n whole power 1 by 2 into n divided by e whole power n. For example, 2 power n versus n factorial.